Thanks for the warm welcome, Brian. Before we get started, I wanted to ask a quick favor from everybody. When I was coming down here, my mom sent me a message, and she said, you better take pictures this time when you go down to New Orleans. So I was hoping to take a selfie with everybody, but is everyone okay with that? Any objections? Thumbs up? Yeah? All right, cool. She's gonna love this. You're making her day. All right, get everyone in, get out of the limelight. There we go. Big Elixir. I took a video and photos. I'm going to throw that in the Slack later. Cool. So how's everyone doing? Good? Yeah. Before we kick into this, can I get one last round of applause for Eric and his keynote? That was wonderful. All right. That's good. It's always nice to come back to New Orleans around a bunch of people who are both smart and excited about Elixir, something that overlaps with me, obviously. So getting into this, starting with who am I? Brian mentioned I'm from British Columbia, Canada, more specifically Victoria. I'm a software engineer by trade, but better said, I'm just the guy with a laptop and too much free time. You can find me at all these places online if you so choose. You can also scan this little QR code I did last night and throw it in your phone. And I'm open to messages basically at any point. After this talk, during the conference, Christmas Eve, if you so choose. I like talking about this stuff. It's not a burden to me, and obviously if I'm up here talking to all of you, it doesn't weigh too hard on me. So please, reach out. My background, for about the last 3 years, I've been writing Elixir in production. This started at a company called MetaLab, a design agency, putting out a lot of Elixir apps for a whole bunch of different clients. That's what kicked it off for me. I'm like, wow, this is great. I love this. I want more of this. I got an opportunity to start a startup for the last 2 years, Futurepet, a veterinary startup, really small, all built on Elixir. That's where this talk came out of. Currently, though, my day-to-day is outside of my comfy Elixir recliner, and I've just dove deep into the crazy world of Haskell. Pray for me. I'm learning types. But I'm working at Fission now. I highly recommend, if anyone's interested in the serverless space, go and check it out. We just kicked it off last month, but we're working on a serverless framework that respects your privacy by default, right? And ties together a lot of cool innovations coming out in cryptography and Web3 in the last year. We're just getting started, though. We just started our first step into deployment, zero config deploys, Fission Live, and you can find it on fission.codes. Check it out, keep tabs. If any of that sounded interesting, reach out to me. So that was Haskell. Getting back into why we're all here, right? This is the title of my talk today. Let business write business logic. And simply put, it's about Erlangs, Lexer, and Parser generators. That's a mouthful. Really, it's just a tale of two libraries that everyone here has in their Elixir apps by default. The first one is Leaks, or L-E-E-X. This is one of those words I've only ever read, never said. So if anyone knows the proper pronunciations, please correct me. It's a Lexer generation library, and it's got a component, kind of a sister library to it, YECC, or YEC, but I'm sure that's not right. Anyway, it sounds big and wordy and kind of intimidating at first, but simply put, it's how you go from a loose sequence of characters to actionable logic. It's how you define languages. And for what we did at Futurepet, it helped us out a lot. So I want people here to come away today understanding what these are, how to use them, but more importantly, I want everyone to come away with permission, right? I want you to feel like you have permission to use tools like this in your application, right? That it's not so scary. That when you're looking to solve problems, there's the tried and true path, but there's a bunch of other less trodden paths. And while they might not work for you, and the tried and true is perfect, there's a bunch of different ways to solve things, right? Elixir's got a lot of cool libraries. Erlang's got a bunch of stuff that they built on for years. The entire ecosystem of programming around us has a lot. So I'm hoping you come away with a broad permission to try new things. And your mileage may vary, right? Someone's scrape bumper is another person's wicked shortcut that just saved them like 20 minutes. Right? So, take it all with a grain of salt, but I hope you find it interesting. Okay? So this is our general roadmap for today. Long-winded intro? Done. Clear. You're good. We're going to kick into the problems, the libraries themselves, just as like an overview, and we're going to do some live coding. When I was asking people, hey, you've given a talk before, what's your one piece of advice? They said, oh yeah, just don't live code. I said, great, what's your second piece of advice? So wish me luck, pray for me if that's your thing, and hopefully I don't have to use this next slide. Hoping. Okay. So first, my problems, because we have to start with a problem before we get to the solution, right? If we start with the solution and work backwards, we basically end up with Corey O'Daniel's to-do list in Kubernetes, right? We don't want that. It was beautiful, but we don't want that. So I'm going to list out what led me down this path. I'm going to explain my problems. So I think we can better put this as the big Elixir does group therapy. I'm going to spill out here, and you guys just console me, all right? So, like I said, the talk was a genesis out of that veterinary startup. It was a small team, and our very first product was simple. It was appointment surveys. And it is as simple as you sound. An appointment is made, we determine what survey to send, we send the survey. And I remember when we were scoping this because I had a particularly good day. I came back from vacation, I walked down the street to my local coffee shop, and for some reason, it was exceptional that day. And I walked back to my house, I opened my Zoom call, jumped in, and we started thinking about, okay, how could we do this? What would go into it? And I'm just sitting there sipping, enjoying it, kind of smiling to myself, and not doing my job as good as I could have, because I was just off in my own land. And as we're going through, some of my teammates are asking what we can do. Like, can we send a different one on species? I'm like, yeah, totally. Sip. Can we send it on age and stage of life? Puppy, senior. Like, totally, absolutely. Psh, got that. And it started snowballing. Breed, appointment type, clinic, certain types of vet, certain times of day, certain times of season. And I'm kicked back on that call with the awesome Americano just going, totally. I got this. I got this. Me and two other engineers? Easy. And I closed that window. The call finished, and I really started thinking about it. I kind of finished that cup of coffee, and I was like, fuck, why did I do that? I have made a huge mistake, because it wasn't as simple as that linear complexity of different field, different field, different field. Where it really kicks us is all the Boolean logic. The ands, the ors, the ins, the nots, the greater thans, the less thans, the equal to, etc. And I'm sitting there like, oh, no, 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 no. And this makes an admin panel more complicated, but not impossible. But at the same time, I don't really want to support this development, right? Because the time you spend on one thing is the time you don't spend on another. It's opportunity cost. You can only have one first priority. Everything else is a distraction. And this would be a distraction when you're on a small team, right? So even if we did build the UI to support this, every little add from MVP to final product, we're touching a bunch of different areas. Can we add this? Okay, yeah, it's quick, but it's still time, over and over again. So before I went back in that meeting, I'm like, okay, let's think about it. Maybe I can think my way out of it. So I was thinking about the admin panel. That's what I wanted to avoid. I didn't want to figure out how to do all those ands and ors visually. I was like, what's some ways I can think about it? So there's developer load up here on the y-axis, system stability on the x, and I was like, well, we could just hard code every rule. The Boolean logic's already there. Crazy, because again, still tons of developer load. Every single change for every single client passes through dev. Bad idea. On the other side of the scale, we could maybe teach business how to code, and they could just edit that file. Terrible idea. And if people weren't ahead of me on that, trust me, terrible idea. Because it would take, even if I was successful to teach it, it would take maybe a day, and I'd come into my code base, and it'd be like this, right? So I was thinking, I just got to think harder. Just think harder. You baby. What was there something else? Something just as good as that admin panel, maybe inside it, but way low on that developer load. Something that let business define arbitrary rules without jeopardizing that system stability while allowing for minimal development effort. You know, essentially, I was sitting there trying to dream up a unicorn. Got a couple laughs. I love that one. Also, don't edit your colors of your slides the night before. This is how you get a purple on purple. But this is where I discovered Leaks and YECC. And we ended up with a solution that was essentially a template language, a Boolean template language. And it worked really well for us, you know, but your mileage may vary. But the simplicity of it and how easy it was is what made me think this is worthwhile sharing. So we ended up with everything from flags to ands to brackets to age ranges to certain IDs, ors, ins, variables. So you could actually constrain the logic that people were writing and keep it as restricted as you need while giving them access to whatever they needed. So before we dive into building this, we have to think about what are the things behind it. And they're new, and sometimes new things are kind of like, what are you doing up there? But trust me, they're very simple. And I'm hoping we're going to take that away today. So first thing is Leaks. You know, it's a lexical analyzer generator for Erlang. It's included in that base Erlang distribution. Its input's a string. Its output is a format that can be grammatically parsed. A lot of big words. More simply put, it's how you go from a sequence of characters and extract meaning out of it, right? It's how you know TRUE is true and you care about it. And that space, don't care. Get the fuck out, right? Same thing. AND, and we care about it. Space, nope, don't care, right? Very simple concept. It's kind of like the peanut butter to this next library's jelly. So YECC actually takes the output of Leaks and applies more meaning to it. So again, it's in all your applications. It's with Erlang, and its output is a tree. Input is that array of tokens. So this is the stage that applies meaning to tokens. So Leaks was, you know, meanings from characters. This is meaning from token. It's how we know that true is just true, and we don't need to do anything with it. It's how we know that and requires two inputs. It's how we know that false or not requires one input. It's how you go from that array to a nice tree and set you up to apply logic to it. So you can imagine the system in a few ways. One is the stages. So we're a Lexer into a parser into our logic. You can also imagine it as files and technologies. Leaks, which is .xrl files, YECC, which is .yrl files, and finally Elixir, which obviously .ex files. The last way, and the way I like to think about it, though you know everyone's brain is different, which is what's so great about the world, is you can think about it as data. You know, we start as a string, true and not false. It becomes an array of tokens, then becomes an abstract syntax tree, right? And finally, it becomes a Boolean. Is it true or is it false? Do we send it? Do we not? Does this apply? Doesn't it? Okay? Do I have everyone so far? Yeah? Ooh, thumbs up. Okay, so we're headed here, right? We're headed to this beast of a template, right? Just this monster, Beast Bob. But we're going to start here. True and true. 3 tokens. Is that right? We got to start somewhere. This is me the other day. So we're going to keep it simple. And if you want to follow along with this, if your laptop's open and you want to tab back and forth between Slack, feel free. Though I have this all sitting in a blog post online that I'll link at the end. Up to you, right? Kicking this off, it's the simple steps: create project, get into that project, create 2 new files, our Lexer and our Parser. So let's start with the Lexer. And this is applying meaning to a sequence of characters. Right? So wish me luck here. Right? So this is that base project. We're just starting off with Hello World. And I'm going to cheat a bit, because I already have them sitting in commits. So I'm just going to go to the next commit, and we'll walk through the files in sequence. So as you can see down here, we have an XRL file, YRL file. We'll start with the XRL file. This is our Lexer. This is what defines the tokens. Remember, this is what tells us we care, we don't care. And for some of you, or probably many of you, who haven't touched kind of Erlang syntax and this kind of syntax, actually, show of hands, has anyone used LEEX and YECC? 1, 2. Oh, hey, this is way more than I thought. This is awesome. Okay, so in here, these definitions, then rules, these are just comments. Line 2, WS, stands for white space, and it essentially defines what we consider white space. Right? At the bottom, we just say for any amount of white space, get rid of it. We don't care. Don't want it. Doesn't matter. The next part, which defines our 3 tokens that we're starting with, false and true. And on the left-hand side, it says if we find an F, then we find an A, then an L, then an S, then an E, that's a token. We care about it. That's false. And then we say this is where it is. And for our demo, this part doesn't matter. It's just more things we have to pass along. And this is what goes into our parser. True is the exact same, as you'd expect, right? And is a little bit different. Where we find A and D, we say it's a token. We mark it with the atom and op, and we're going to match on this later. We say where it is, and then here, this is list atom token characters. This just says take the characters we found and put it in an atom. So essentially, this is just and. And that's it for the Lexer. And it reads fairly well when you get used to the syntax, and it's not many lines of code. Like a good chunk of this is actually white space and comments. So, and you can actually run this right away. Like everything in Erlang is callable directly from Elixir. So if I pop open my IEX, call out to it, business, Lexer, string, true, something like that. It finds it. It says that's true, right? And we can go true and false, right? And it finds that, right? It sees all these tokens. We could even go true and, right? Something that doesn't make sense, but it's still tokens, so it's still like, this is okay, right? We haven't applied meaning to the tokens yet. We've just applied meanings to the characters. So this is where I actually missed the slide. But you're going to get a nice GIF right there of Stephen. The next part is the parser. So this is where we take that output and put it through and apply meaning to those tokens, create that tree, right? So going back, if I open that .yrl file, business parser, again, it's not big, and it's all about pattern matching here. So like any tree, we have the start of it, the root, we have where it ends, and then we have like certain patterns in between, right? So starting with the root, we just say it's an expression. And what is an expression, you ask? It's defined right below. An expression could be a Boolean, and in a Boolean's case, a Boolean is either a true or a false, and if you find that, return true or false. Nothing groundbreaking there. Expressions are also AND operators. And this is where it kind of gets interesting, right? So we find that AND op, and we know that we care about what's on the left and what's on the right. So we grab both of these, and we return and say this is a binary expression, i.e. it requires 2 inputs to evaluate. We tag it that it's AND operator, and we give it its left and right. So this is the format that actually comes forward into our Elixir app, which we'll get to in a sec. And that's it, right? Just matching down to what's the pattern we expect these tokens in. What do they need? And admittedly, this last line at the bottom is unused. I forgot to remove it, so ignore that. All right. And we can actually run this as well, just so I don't forget. You guys ever been fancy walking? It's exhilarating. All right. So I think I got that saved further back. This is where I put my safety rails on. So here, we've got true and false going into our Lexer, taking the tokens out of it, and then going on to our parser, right? Just piping it through. It looks like there's more to the eye there than there actually is. But as we put that through, it says, great, that's an AND operator with true and false, right? And we can go all the way back to the start and go true and false and. And that's where that tree structure starts kind of coming out, right? And we also have the concept of meaning. So if I was to say just and, it would get mad at me for that, right? That doesn't make sense. If I was to go true and false, or just true false, right? Again, it doesn't make sense. It complains about it, okay? So right here, a lot's coming together and not a lot of code. Going back to our sweet, sweet walk. The last part of this is the logic, our Elixir functions, right? Reducing to that Boolean answer. And this file's a little bigger, but it's not very complex. So .ex. So we essentially have three functions. One's an entry function, the other ones are applying the logic, and it goes top to bottom. The first one is evaluate, which is just a nicer way to look at what I just had in the terminal. We have the expression, or the string, we pass it through the Lexer, we take the tokens, we pass it through the parser, we take the tree, we evaluate the tree. This is where Elixir comes in. Evaluating the tree, again, is just matching, like before. We're just matching and looking for these patterns. First thing we do is let's look for binary expressions. If we find it, we have to evaluate the tree on the left and the right. Evaluate tree A, evaluate tree B. Then we apply logic. And for everything else right now, it's very simple, so we just say apply logic. And apply logic is just where we start exposing these Elixir functions, or just these programming concepts. So when we find a Boolean, true and false, we return that Boolean. When we find a binary expression with the AND operator, we check that they're Booleans, and we return the result of A and B. That's it. Like that's the whole concept of these two libraries in combination with Elixir. All right, so even running this, and can't forget the GIF. You guys ready? I want a dog so bad. So bad. My wife's watching. Okay, so going into this, and we can call out to that. So Elixir parser, evaluate true and true, right? That's true. It'd be amazing if it wasn't. So we go true and false, false, right? And you can keep kind of training that in there. And if we have tokens that it doesn't understand, it gets mad about it. If we have logic that doesn't make sense, doesn't like that, it's already pretty powerful, again, from very few lines. All right, so we did it. We did it. Give everyone a round of applause. I like when people respond to that. So that's the whole concept, right? That is it. And to kind of prove this forward, how easy it is extending this, let's add just a couple simple things, okay? Starting with the hardest one, variables, right? How do we, get things in here? How do we give that business team things and data that they can use and care about? Right. So going back over, terminal, going to exit out of here. Going to go for that next commit. Great. And I'm going to start highlighting this so you guys can really see. Kill that. We're going to go into Parser. No, not the Lexer. Okay. So again, not much has changed here, and I'll show you exactly what changed. Some white space, a new definition, and a new tag, a new atom. So we say here, we've got the variable. It's A to Z, capitals, lowercase, doesn't matter, underscores, numbers, and any number of them. That's a variable. When we find one of these, we tag it as a variable, and then we pass what the variable was onwards to our parser. Not hard. In that YRL file, if we toggle these annotations, 3 things are added. And again, very simple. Terminals, where we stop nesting in and looking more, variables, right? Done, you found it. Woohoo. Expression can now be variable. And we just say, extract that string value, extract the variable out of it, right? Extract the name of the variable. And we touched a whole bunch of functions in Lexer Parser, but just to pass the variables down. So, yep, there we go. So we have the variables come in, we pass it to evaluate tree. Evaluate tree keeps passing it down all the way to apply logic. And in apply logic, if we find a Boolean, we don't care about the variables. If we find an AND operator, we still don't care about the variables. However, when we find a var, we do care. And we just say, hey, given this variable, find its value out of this map and return that value. Error if you don't find anything. I don't have it. And again, this is really, really simple. And I'll run this again. Another nice GIF. No ice cream. So back in here and jumping into that terminal, we can go Elixir Parser. I think I have it kicking a little further back. So evaluate true and A, true and false. Oop. Oh yeah. Of course I would pick the one, but I had a syntax error. False. Right. True. Right. It's a couple lines, one function signature change, and that's already in there. Right. And it just keeps going like this. Right. Even to add in not, which is an unary expression, again, it's not much more. So we go next step. Right. I'll go over here. I'll close that file, and we're going to go in the XRL again. Now we have not. One line. Right. It's the exact same as the AND operator. We go into the YRL file. Again, pop this open. It should be 2 lines. We say it's a terminal, and then it's almost identical to the AND operator. But this time, we know the only thing we care about is to the right. When we find this, we just tag it as an unary expression instead of a binary and give it the one value it cares about. That carries forward again. Right? And in here, it's just one more definition. So we have a new evaluate tree, which is nearly identical to binary expression. We just have one less thing to evaluate. At the bottom, when we find the not operator, we just apply the not operator. Nothing groundbreaking, but again, there's a lot of power that comes out of this really, really quickly. So going back to use superpower, right? So glad I found this. So glad I found this. Because, and to get like this last point across, right, while we're all here, we can go not A. Right now it's false. And this just continues to snowball. So with this, you can extend into a lot of things. And originally I said we're going here, right? We're going not, ands, brackets, the whole kit and caboodle. Never use that word. But not in the way you'd expect, right? So this is the last part of the talk. The rest of the owl. This is what the functions or the files look like with all of that. And while it's more lines, they don't get more complex, really. A couple extra functions, but I mean, list to atom, list to atom, list to binary. It gets verbose that way, but you're not really having to learn many new concepts, with the exception of precedence. But again, it's just giving it a number. Not too difficult. And if anyone's thinking about using this stuff, this is where I get really enamored with the Elixir community in general. We are a new language, relatively, but we have a lot of libraries, and we have a lot of people who are passionate. There's a reason everyone's here in this room learning about this stuff and learning, or with me, listening to me kind of talk about it and hopefully not boring you to death. But if you don't want to write this out, there's actually a library that does this. And full disclosure, this isn't my library. This is one that we pulled in and contributed to. It's run by Yasmiel Pons. He's a developer out of Fort Lauderdale. And he made a really powerful, solidly tested piece of code. We did a lot of property tests in there. It worked really well. But it does everything for you. So if anyone's sitting here thinking, this might solve a problem for me, or this could solve a problem, or I'm just interested in it, check it out. Go look at the code. And you don't have to take my word for granted. It works, and you can try it. This is where we get to stand on the shoulders of giants, or the shoulders of our community around us. So thank you so much for listening. I appreciate it. I appreciate the big Elixir for inviting me here to speak. This is a wonderful event. This is a wonderful city. And thank you to all of you who come out and do these things. Because without events like this and the people who attend them, great ideas would never really get going. We wouldn't have these new languages we love, these frameworks we appreciate, or these libraries that we can then in turn use. So thank you. And yeah.
Thanks, Ben.
Any questions?
Oh, questions?
Sorry, Brian.
No, it's your show. It's still the Ben show.
This is where I'm always terrified. I'm like, I don't know if I can answer the questions.
So most of what you were showing there was creating Boolean results.
Yep.
Have you expanded on that to do kind of, to tie things into various actions and kind of create more full programmatic structures that are doing a chain of operations on things?
Nothing too extensive. Where this got a little more advanced, and not much, was when we got into the idea of competing templates and introducing the idea of priority. Say if 2, 3, 10 different templates matched a given set of criteria, which appointment, reminder, survey do you send, right? And that just came into giving people a value and you evaluate them in order. But we never got it really past, is it true or is it false? Mm-hmm. Or tying them together.
No. I mean, I had similar needs recently, and it was completely unaware of this, and it would have been really interesting to experiment with. So I really enjoyed your talk. Thank you.
Oh, good. Thank you.
Any other questions?
Anyone else?
How did the pets feel about this?
What was that?
How did the pets feel about this?
For the most part, really good. Admittedly, in our very first iteration, what we found out is data from veterinary clinic servers way in the back of the closet was very unreliable, and we may have once reminded someone of their dead cat. We sent them a goodie bag, and we felt very bad about that. But that wasn't because of this. So for the most part, they're pretty happy.
Good.
One exception.
Thanks, Ben.
No problem. Thanks, everyone.